Moving on to task 4, since we are done with task 3, this talks about regular expressions, changing them from NFE, Thompson's contractions, building blocks. A symbol A becomes a second state fragment stat A, and concatenation joins one fragment into the next fragment stat with an edge. So, for part A, rejects to NFE for each of the seven regular expressions. Several, for the seven regular expressions. Yes. I used convert RE to NFA in JFlap. We typed in the expression and JFlap just built it up piece by piece using Thompson's constructions. One small machine for each symbol, then wires them together with epsilon transitions for concatenation, union and star. Yes, as you can see. So I did this for the seven expressions. Yes, one per expression, and for each one I pause to explain in my words what the expression actually matches. So for example, 0 plus 1. I said this just machine I said this just matches literally any string of the OS and the 1S. That's the zeros and ones. Yes. Including nothing at all. So the zeros and ones matches each other including nothing at all. And then for the parts, so this is it. So moving on to the part B, given transition table AB, column start state K0, then accepting states K2 and K3. So this is the transition table. So this is the state transition diagram. So what? K0 as the start state, and then K3 and K2 as the accepting state, final state. So you just here, note K3 has no incoming edge from K0, K1 or K2. It's on its own. It is unreachable from the start state, so it never affects which strings the machine accepts, even though it's formally an accepting state. I'm going to share how I drew them at the end of the video using JFlap. So here is a regular expression via elimination. So here from S to K0 label we receive this. So from K0 to K1 you receive A. It goes both ways. From K1 to K0. From K1 to K0 you receive A. From K1 to K0 so we receive A. From K0 to K2. K0 to K2 we receive B. Yes. From K1 to K2 we receive B. So yeah. So on goes. So and for the B2, for the last part, I built the four state machine directly from the given table K0 to K3 in J flap. In J flap. Yes. While drawing it, I pointed out on the camera that K3 never has anything pointing into itself except itself. Yes, this K flap is just so in K flap K3 is not pointing to anything except itself. It's standing on its own. So it can never actually be reached from the start state, meaning it doesn't affect the language at all. Then I used convert menu to convert FA to RE. Again, clicking through the elimination of K0 then K1 and read out the final regular expression J flag product. Yes, so they produced that K3 is pointing to itself. To wrap up, I typed several strings like B, AB, and AA into a multiple run and show them all being accepted. Yes. So thank you. This is the end of the explanation of task 4. Okay, so with the task 4, this is the transition diagram. Okay, so first, okay, let me zoom this. Okay, it's here, then here, and here. Okay, let's first set the name. Okay, 3, set them to K0, set them to K1, set them to K2. Okay, so make this the initial state, and then both K2 and then K3 are final state. So start mapping to each other. Okay. Okay. Add, add this to this. A, not K1 to K, A, K1 to K2, input A, K2, and K2, not K2 to K2 to K1, input B. Okay. So this is then K3 stands on its own. Yes. So remember earlier I told you to note that K3 has no incoming edge from K0, K1 or K2. So it is unreachable from the start state. So it never affects which strings the machine accepts, even though it is formally an accepting state. It doesn't affect the machine. It doesn't affect the machine. It doesn't accept anything. It just accepting its own thing. Even though it's an accepting state. Yes. So any input of strength over here that happens over here doesn't accept this K3.